Yeah. You can start from the beginning. It's okay. We forgot that you had like, let's start again. Not presentation, not the introduction.
Not the intro. Okay. So what you can see here is that linear regression on the left with just some data points and a trend line through it. And on the right side, you can see this example from ChatGPT that I asked yesterday, what is Germany famous for? So with the linear regression and with most classical machine learning and even deep learning models, it's quite easy to evaluate them. So it's quite intuitive to think about this is a good trend line because it covers, in a sense, it's a line of best fit for all these points, and it is quite close to most of these points. And similarly, it's really quite easy for us to also express this in mathematical terms. So we can use a variety of metrics for that come quite intuitive. Like we can use a mean squared error, an R squared, a mean absolute error, and many more. It's quite easy to go through that. But then when we go into something like large language models, here, if we just ask what is Germany famous for, and it comes back with car industry, history and culture, and beer and Oktoberfest, this initially seems like a pretty sensible list. And I would agree with that as well. But Natalia here, on the other hand, might disagree and say that actually Germany is really famous for pretzels or for being home to the largest zoo in the world.
Is beer there?
It is.
Okay.
So I guess my point with that is depending on the application, depending on the use case, the same answer may actually be quite differently judged, whether it is good or not. And similarly, it's not that simple to just have a numerical value that tells you, okay, this response is better than another response that ChatGPT could give you. So what we want to address with this presentation is how can we actually go about assessing whether a chatbot is better or worse than another one, and how can we make sure that we assign some kind of quantitative measure to saying this chatbot response is better than another or worse than another. And with that, over to you.
You can take a seat for me. So can I use this? Okay. So Fred hinted about a couple of things we want to cover, but in general, like in this presentation, we want to talk a bit more about motivation. So we started why Gen AI is not your typical AI application, it's not your machine learning. So it's really different, and there are some challenges connected to this. Then obviously the topic which is really close to the heart of not only data scientists but software engineers, why test-driven development is really kind of like key and what it enables us to do. Fred will go into metric selection and the evaluation framework implementation that was done at BP, and we'll cover some lessons learned, so maybe it will be useful for you as well. Okay, so what we don't cover in this presentation, we're not going to talk about benchmarking of models. So we won't be comparing one model to another. So I think inherently some of these things can be used to compare those, but today we'll be just focusing on more application-based things. So what is so different about Gen AI? We talked about it's more measurable, but historically, like if we, not historically, but if we just go back and look like 2 years ago, like less than 2 years, but almost 2 years ago, this whole thing with ChatGPT appeared and everyone got super excited. So we saw a lot of business users coming to us and bringing this technology and saying we need to use it, we need to apply it. And they were super excited. So there were a lot of POCs appearing. So loads of POCs, loads of interest. And it became extremely evident that if someone comes and said, I want to bring this to production, but they have no clue how to kind of test it or how to assure that what they want to bring to production is actually working, it's slightly a problem, let's put it this way. So we've seen a lot of these applications creating POCs super fast and trying different things, reaching some level of performance and then kind of almost stagnating. So like they wouldn't kind of move because they wouldn't have any metrics to understand. So you would make it better in one place, you will completely destroy it in another place, and it will become really, really subjective. So you wouldn't have a lot of production use cases because productionizing Gen AI is like different. So why it's different? Because it has hallucination. So hallucination is a beautiful thing where Some people like just chatting for the sake of chatting, but usually in business applications, we use GenAI to create some business value, to answer some questions, and we need precision. So we want the information produced being true and reliable. So if someone comes and says, like, I have kind of like a feeling it's correct, but maybe there is some bullshit there. It's a hallucination. You can't rely on this data, so you can't bring it to production. You can't trust your business being reliable, rely on this. So you have a lack of trust from the business users. So first time I think someone found this anecdotal thing. It was all over the news. I don't know. I think Fred was showing me the one who discovered Germany or something was the question, and Igor ChatGPT said, "Yeah, was it, I don't know when did Columbus discover Germany?" And ChatGPT gave like an answer, especially at the beginning, and gave you some information really like looking trustworthy. And what I already mentioned, small changes in the prompts can completely ruin everything else which was working really well. So, and those changes are really small ones. It can be really like tiny ones. So how do you understand that you're moving in the right direction and like things are becoming better and not actually getting worse? So what we said, in order to bring it to production for some business to be relying on it, we need to trust it, and we need to trust the performance. So we need to actually prove to the business, to people approving it technically that it works, and we can rely on it. And yes, so we need some reliable development cycle. So I think what happened at the beginning, people started developing and they were not quite sure how to move forward, like what things are the best practices. And I think still it's like you have a lot of frameworks that were built in this space, but especially at the beginning, it was a bit of software engineering best practices. I've seen some documents about testing, which were just copies of software engineering test strategy, usual one, a bit of data science. So it's like several worlds kind of like coming together. So we want something reliable in our responses. We want free of hallucination. We want to have appropriate tone for our use case, and we want to have a scalable process. When you're building one GenAI application and you bring it to production is one thing, but what if you have 100 of them and you have one team doing several of them? You need to think about something that will scale, because it needs to be shareable across the teams, and it needs to be repeatable, so we don't have to invest in this activity every single time. I will just remind about the basics of how we can work with LLMs. So we can either do some prompt engineering with them, so modifying how we ask questions to get the results we want. And there are now some really sophisticated ways of doing prompt engineering. You can do RAG, retrieval augmented generation. By the way, who knows what RAG is? Majority. So, but just in case, I will cover the RAG part in the next slide, but really briefly. So it's retrieval augmented generation, more or less, retrieving some information before answering questions, so giving the system some, and fine-tuning. So fine-tuning is already changing the parameters of the model and kind of playing with it and adjusting it, so it's like much more involved process. But more or less like moving from easy one, it's like prompt engineering, RAG, and fine-tuning. So most applications we see actually use RAG. 80%, I would say, what I've seen in our kind of use cases are RAG-based, where you have, as I said, the retrieval part. So you retrieve a context and give a context, which is your documents. Any documents can be structured, unstructured data. And then based on this information only, you produce an answer. So where you have like this data storage stuff in the middle. And yeah, as I say, like you have different sources of data. It can be a structured one, it can be completely unstructured one. And then in this way, your LLM, your language model, knows about your company. So you don't have to do anything, but you just like bring it knowledge and say, okay, so I give you all this information, just like based on it, like almost summarize or like produce something. So many metrics we will be discussing today are actually connected to this concept. So we either have, it's like this RAG thread will be referenced by Fred. So we have a query, response, and context. So query is something a person asks. So I ask, what's the capital of Germany? Then I have context, so I go to my database and it retrieves me all the things about like Berlin's capital of Germany. Berlin became capital in 2005, I don't know. And that's our context. And then I have response. So I looked at whatever context I've seen retrieved by information retrieval, and I created the response. And when we evaluate the performance, those three things can kind of like be affected. And that's where you can have like different areas occurring. So we'll come back to this when we talk about different metrics. Talking in general about RAG use cases, so they're also not so simple. So even though it says like RAGs is like the technique, you have also different versions of it. So it can be external facing, it can be internal facing. So here we have some examples, and they're quite typical for internal ones. For example, for knowledge management, we have so many people getting excited to chat with your data. I can see everyone coming and saying, oh, I just want to chat with my data. Why? It's okay. We'll decide later, but it's so exciting. Like I have all these documents no one used for 100 years. Now I have opportunity to actually, like ask questions. I'm not sure they will ask questions about all these 100, but the whole excitement. Working with all legal kind of processing and asking questions. And obviously external ones are the well-known ones. So if you contact a big now customer that, I don't know, Amazon or like other ones, first you will have interaction with the bot in some way, and then only maybe you will talk to a human if you need to. Obviously, you have also non-chatbot RAG applications and non-chat. So not every single RAG is actually a chatbot. That's what I want to say here. So you can have a RAG approach applied to, for example, processing contracts. So it will be a RAG, but it will be done like I give you a contract and I want some information being summarized and but I don't want to actually have it in a really interactive way by asking questions, but more it's like a batch processing. I send documents, they get analyzed, the information gets extracted, and we move on. And obviously chatbots without non-RAG ones, non-GenAI ones still exist as a concept. So when we start talking about evaluation, so we talked a lot about why we want to evaluate things and why it's important and why GenAI is slightly different. So now we can move to kind of revising, trying to remember what we know about evaluation. So you have generally two options. You can either do it manually or you automate it. You have in the middle like kind of like semi-automated, but like, yeah, you have two opposites, manual or automated. So obviously, human-led evaluation, where you have a human in flesh sitting and doing the stuff, is really good, but it has some shortcomings. Shortcomings being you have like it's quite expensive to have a human in the loop, so you do not usually have a lot of those people, and they want to sleep, for example, they go on holidays, so they're less reliable. Let's put it this way. But it's really reliable because if you need to, for example, sign off a process or you have some big release happening, so you really want to have humans judging the application. Let's assume what we said. We have 100 applications and they have release cycles happening from time to time. Where would we find so many humans? And obviously, going back, we have like really small, like a lot of different companies that provide you humans like for really simple tasks and say, okay, you can use them to do some annotation. But usually, when we talk, for example, I will take example of our company, we have a really specific application. So any human won't be good. It needs to be a subject matter expert. So someone who spent, I don't know, 20 years working as a really engineer. So those people are scarce and that time is, yeah, really valuable. So it's not really feasible for recurring testing also because it's really boring for people, just like answering the same. Isn't this answer correct? Yes. Okay. Does it like, is it like complete? So it's quite boring. So next we move to something which was available even before GenAI, and we're going back to natural language processing metrics. Rouge and Blur were used a lot in translation and in summarization. Those are metrics which are calculated automatically, but what they look on is, I think, similar on the surface. So if I have a reference translation and I have a translation produced by a machine, how much stuff is overlapping. So those ones are produced just by calculating overlap, as it says here, overlap on words, and they're automatic, but obviously if we go back to GenAI solution, so GenAI solution can answer in so many different ways. So sometimes words won't be an overlapping at all, but the essence of what GenAI will be producing will be correct. So I don't have any example about like Germany, but yeah, I can say that Germany is famous for beer and great cars, or it can say Germany is famous because all the breweries are so amazing and Volkswagen is being built there. So there won't be any overlap, but holistically it will be more or less the same. So there is a problem with this type of relation, which brings us to something which can be available for GenAI evaluation framework. And here, I think Fred will be introducing you to the concept. It's LLM as a judge. Not all LLM as a judge, but yeah, so combination of those things. Trying to optimize time of human spent, so you will still maybe will have reference annotations done by human, but it's something that you can do recurrently, and you can run through this testing much more often. So you don't have a link of like human being sitting in the office next to you and actually how much stuff you're checking. So obviously, small bit here. So this evaluation needs to be still checked by humans from time to time, because otherwise you might have like some place where automation doesn't work, so it doesn't remove human completely, but it really kind of like makes it a bit speedier. So we said, okay, we want to build some evaluation framework, and we think it's really available to have something which is recurring and it's automated. So what are the things we have to ask before starting this, even like looking into this? First is, what do we want to measure? And that's what I think Fred referred to. And let's think about your particular application. Here, the thinking is really similar to what you would do in AI space. So it's a really well-known thing when they say, okay, so I have two applications which are detecting anomalies. So one application is detecting anomalies like fraud on my bank account, and I really want to be alerted like all the time, you know, even if it's not correct, I just still want to have a call. And my metric will be different to some other applications where I will be like, even if we miss something, it's okay. So here is also how precise you want the answer to be. Is it like just chit-chat, chatbot where you get information, I don't know, about best software engineering practices? Or is it a chatbot that actually gives you advice about, I don't know, some ways of acting in safety environments? Requirements to these metrics will be different depending on your application. So yeah, is context relevant? Is answer free hallucination? So will be also dependent on your particular application. What does good look like for chat response? So do we need it to be exact? Do we really care about it being correct, or do we want to focus it on delivering something and not like kind of bouncing back saying like, I don't know what you're talking about? So, and yeah, those next questions will be the ones Fred will be kind of like talking. So once you say, okay, I want it to be automated and I want to automate, how would you actually automate things? And how would you make the process repeatable and consistent? Way to fly and to be adopted across organization. Also, it needs to be quite flexible, repeatable, because every application is really specific. So it might want to adapt something and not something else. So I think we were looking more at enterprise level, where we want to build solution which can be used by many not companies, but many teams. So how can we also make it like reusable and fast, so people see it as a benefit to their process rather than a hurdle of something that like adds a lot of over additional stuff. Okay, so at this part, we give to Frank, who will tell you about the solution.
Thank you. So thanks for this great introduction, and you've kind of really outlined really nicely what the problem space is, why we care about these things, and what makes this different to classical machine learning. So what I'll do now here is offer a solution approach of how we think that this could be addressed, both at a small level, but also at an enterprise level, so that it can be adopted across multiple teams. And what I'll start telling you is our LM as a judge implementation. So essentially, I'll start with how do we measure something? Then we'll go into what do we want to measure? And finally, what have we learned while going through this process? So just as a reminder, or before we go into more detail, I'll flash up a couple of these slides that Natalia has already walked us through, but just to give a bit more of a introduction to what we're doing. So we've already kind of talked about human-led evaluation is way too complex, way too costly, and just not feasible overall. These NLP metrics will do some part of the evaluation, but will not capture the intricacies that we want to measure. And an evaluation framework by itself will help us create scalable evaluations in an automated fashion, but at the same time, we can't really just trust just an automated evaluation. So really what we're proposing here and what we want to do is a human-enhanced evaluation framework where we automate the evaluation, but then we have a human in the loop that is able to validate that what our evaluation is actually giving us is actually correct and scalable. So before we jump into the actual framework, what we want to do, or what we want our framework to do, is we want it to be scalable. So we should be able to evaluate sets of questions that are larger than 100, 200, maybe 500 questions that we want to use for our test set. We want it to be flexible. Natalia has already outlined that a metric for one use case may not be so relevant for another use case. So if you have, for example, a financial or a legal domain, it might be really important that your answers are crisp and correct more than anything else. If you ask something about a contract and it tells you something about this contract that is wrong, then that's obviously no good. But then if you have customer service or external facing applications, maybe you have a bit more leeway as long as your response is somewhat relevant to the question and not offensive. So that might be a much bigger priority for that as opposed to for an internal application. Then it should be extensible. We propose on the next couple of slides a couple of metrics that we think are a good starting point for most applications, but any given application may actually have their own set of priorities and their own set of metrics that should be used to evaluate it correctly. And we want to make sure that our framework is easily extensible so that any project team can just add their own metrics and run it with that. And then finally, reproducible. It's no good if our evaluation framework doesn't produce the same answers for the same question and response pairs. So if you have 100 questions that you run and you run the framework twice or 3 times over it and you get different scores over it, that doesn't inspire trust. So we need to make sure that whatever we build is giving us consistent outputs. Then what do we want to evaluate? Again, we're defining here, or we've built our framework in especially for RAG applications. It's not necessarily just focused on just RAG applications, but that's where what we focused on here. So the way to think about this is for RAG applications, we want to answer some question with the help of some data that we've retrieved in some way. And all of these sums are things that we want to evaluate and that we may want to optimize for. So this is, again, kind of where this RAG triad comes in that we want to optimize for. And you'll see this slide one more time in the end with our annotated metrics. We want to our evaluation metric should cover these arrows here. Can I laser point? I can laser point. So these arrows here, this one, and this one, this is where we want to place our evaluation metrics for. So for example, one metric could be how relevant is my context to my query. So this would place in this arrow here. And similarly for these other two arrows, we want to cover them also well enough so that we have trust that our application covers them well enough. Then we already foreshadowed how we want to measure things is using a prompt-based evaluation. And the key idea is basically that we can evaluate whether a response is correct or not by taking a response and a reference answer, the reference answer being what we would have expected the response to be, and asking a judge model. Usually we use bigger models for them, whether it's GPT-4 or maybe O1 or one of the other vendors' models. And we want to basically ask it with a very detailed prompt where we outline how to evaluate it. And we want to ask it, can you assign a numerical score to how good this answer is? And to make this all in an automated fashion, you start with a benchmark of questions. Usually, I would say, or we would recommend around more than 100 questions to start with, and you need the expected answers for those 100 questions as well. Then you pass in those 100 questions into your RAG application. At this point, you're not necessarily doing anything innovative yet. You're just having 100 questions and you're passing them in your application the same way you would interact with it as a user, and you get some answers here from it. And then these are your model answers, and then you use the model answers and your expected answers, you feed them into your judge model and get an evaluation result from it. So I think the key question here is now, how do we actually do that? So if we just for 1 second go back here, the judge model is what we want to dive into now. And how do we actually build a prompt that can evaluate applications for us? So we'll start with the same way as always with a system message. So we set the scene for saying you're an expert in chatbot response evaluation, and your task is to assess the correctness of responses against their expected response. So this example is for the metric of correctness. We would then go into defining what the metric is. Usually what I would say is a correct metric is defined as something that is factual correct. It doesn't have to be fully correct as a factual correctness in the sense of if everything in the response is correct, then it's considered correct, even if things are missing from it, as long as it doesn't introduce new information that are wrong compared to the reference response. So, but you can define, this is the beauty of this, you can define your metrics however you like and however it's suited for your use case. You then give it instructions. So the instructions would be, how do you actually come to evaluate it for this metric? These are quite standard examples here, like think step by step. So use reasoning through it and then compare key points also of the response and the expected response. So the way to think about it is that if you have a pretty long model response, so let's say you have like 2 or 3 paragraphs, and your expected response is the same way, what you might prompt your large language model to do is to first write up a summary of both of these responses and outline what the key points that are being made are in those 2 response variations, and then compare those key points rather than comparing it just on the face of it. And usually by splitting up this task into multiple subtasks, so really thinking step by step, that helps to ensure that your evaluation is pretty consistent. Then you might give some more detailed instructions. So here, for example, we tell it what scale we want to evaluate on. We can do it from 0 to 10. We can do it from 0 to 500. We can do whatever we like in that case. But usually a standardized metric is the most suitable for this. And you might give other specific instructions for that as well. So I've worked on, for example, on 2 projects in the last year. One of them was more focused on being able to get quick and detailed responses, whereas the other one was in the financial domain where we had to be really precise and correct for it. So what it means for a response to be correct and good is quite different for both of these applications. For the financial domain application, you need to make sure that whatever your response is, it's 100% the same thing as your contract says. Whereas for your other chatbot response, it might be that if your response contains more information that is kind of sensible than the expected response and adds more flavor to it, that's actually acceptable as well and shouldn't be counted against it. So really, with these prompts, you can implement quite a lot of granularity on how you would like your model to be evaluated. And then finally, we have few-shot prompts and your input. So I usually recommend giving 5 to 7 examples and really be clear and exact in your examples as well to show how you would like the LM not just evaluate it, but also think through it step by step. Cool. So what we'll do here now is we'll present some of the minimum metrics that we think are reasonable for most use cases. And we have split them here into 2 categories. One is the context quality and one is response quality. So we start with response quality here. And the metrics that we're looking at here are correctness, completeness, clarity, groundedness, and answer relevance. The first 3 are pretty straightforward. They're for correctness, so is it factually correct? Is it based on the ground truth? Completeness, if you think about this example that I gave earlier, if you list up all the key points of the response and then compare them, if all of them are matching across your experimental and your model response, you can say that this is probably a complete response. And then clarity, is your model response clear and coherent and doesn't include a lot of waffle. And then finally, we have these 2 here, groundedness and answer relevance. Groundedness groundedness basically means that if you retrieve some information to answer that question, so we saw that rack diagram earlier, that all of the information in your response is actually covered or based on the information in your context that you retrieved earlier. And then finally, answer relevancy means that the response to your question, the response that the model produced is actually relevant to your question. And importantly, you have to distinguish here that relevant doesn't mean that it is correct. Like it can be completely wrong, but it might still be a relevant response to it. And in the next couple of slides, I'll show an example of that as well. But before doing that, I want to highlight 2 implementation details here as well, which is whether you need a prompt or prompted embeddings or human annotated data. So human annotated data is perhaps a bit simpler to understand. For correctness, completeness, and clarity, we need to provide a test example of what we wanted to compare against, whereas for groundedness and answer relevance, we can evaluate these 2 without having the actual answer that we expect there as well. And that's quite relevant because what this means basically is that for correctness, completeness, and clarity, this is basically an offline metric that you have to run, whereas groundedness and answer relevance, you can run this online as well and make sure that before, for example, before you return an answer to a user, you might want to check whether it's grounded and relevant. And if it's not grounded and relevant, you might just reject that answer similarly to how you would reject a safety violation and not return it to the user. And then finally, we have here this column here that says prompt or prompt plus embedding. And the way to think about this is for these 4 metrics here, correctness, completeness, clarity, and groundedness, we can do this with this LM as a judge implementation, as I've shown it a slide ago, by just explaining what is the metric and letting it compare these 2 things. Answer relevancy, there is a really neat way of implementing that, where you take the answer that the model has given and you use your LLM to generate what the question could have been for that question, for that response. So let's say, we'll see an example of that, but let's say we'll ask, what is Germany famous for? And we have those 3 bullet points that we've seen at the start. if you were to just see the response and then think of what could I have asked to get that response, you would probably come up with something along the lines, what is Germany famous for? And then you take your reverse engineered question and you compare it against the actual question that the user asked. And if they're similar, that means that most likely your answer is relevant to the question. So let's look into an example. Here again, where is Germany and what is it famous for? The model response could have been Germany is in Western Europe and is famous for croissants and the Eiffel Tower. And the expected response is like earlier that Germany is famous for the Oktoberfest beer and pretzels and bread varieties. So it is hopefully not very surprising that this has a low correctness score, a medium completeness score, because we were able to figure out that it is in Western Europe, but we've missed that second part here. And it has a high relevancy score for that exact reason that I've just mentioned. If you just see this response here, you could very easily infer that the question was, what is it famous for? Meaning that the response is actually very relevant to the question. It's just wrong. So let's try a slightly different example. This time, same question, same expected response, but our model response is just Germany is in Western Europe. So here, in contrast, we have high correctness. We say that factually everything that the response has given us is correct. Even though things are missing, doesn't matter, it's factually correct. It is relevant or medium relevancy because at least part of the question could be easily reverse engineered. And it has low completeness because a key part of it is completely missing. So this kind of showcases the difference between correct, complete, relevant, and that you may want to evaluate some or all of these depending on your use case. And when making changes to your applications, you may also prioritize one or more of these metrics. And then one final example here where we look into, again, same question, similar response, and same expected response as well. And we give context here as well. So we say our response here is Germany is in Western Europe and is famous for the Oktoberfest. And we have the context here. It's famous for varieties of bread. It's famous for the Autobahn, and Germany is located in Western Europe. So here what we want to do is we want to, again, look at correctness, relevance, and clarity. And these are high because it gives you the right information. But groundedness and completeness are lower. So we're missing here beer, pretzels, and bread varieties. So clearly the answer is not as complete as it could be for this use case. And groundedness is also low because even though we have relevant context, the context doesn't actually give us the information to come up with this model response. And ideally, again, if we think back onto that RAG triad that we've seen earlier, we want to make sure that for the metrics that we care about, we measure and are optimizing for all three of these arrows that we've seen. So let's move on to context quality. So far, everything that we've talked about was about response quality. How can we make sure that our answer is correct? So let's quickly look over context quality. And context quality can be essentially separated and measured in two different ways. Recall and precision, and meaning here, the questions that we ask ourselves here is, does the context contain all the information that we need to answer that question? And does it rank the information that is most important most highly, so that we can see that if you retrieve some context, at the very start you see the relevant information, and then it kind of comes with supplemental information. And that's basically what context recall and precision are doing. And again, we're measuring it in the same way with prompt engineering and LLM as a judge. And because it's all about the context, we don't need human annotated data to come up with that. So one more example here. Here, question is same as before, and our response is actually the perfect response, or the expected response is obviously the perfect response. And we have context here saying Berlin, Germany's capital, is home to the largest zoo in the world. Germany is in Western Europe and home to the Oktoberfest, and it's famous for sausages, pretzels, schnitzel, and bread varieties. So what we can see here then is that this context contains all the information that is needed to come up with this expected response, but it does not contain or it's not ranked in the right way. So we don't expect actually the information about the zoo to be in the expected response. So it's still relevant, it's still helpful, but for this particular question, the precision is off because we would have expected these two here to be higher ranked. So that's kind of the difference between context recall and context precision. And that becomes especially then important if you think about context windows in LLMs. So you want to make sure that your most important information comes first. And then one more time looking at that RAG triad here, and you can kind of think about where all of these metrics then come into play. When we think about the query and the context, we want to make sure that is our context good? Does it return the right context ranked in the right way? When we think about the intersection between response and context, we want to make sure that the response that we're generating is grounded and based on the context, doesn't introduce new information that isn't in the context. And then finally, when we think about the response compared to the question, we want to make sure that it is complete, is it correct, is it relevant, and is it clear? And then again, this kind of depends very much on what the use case is and what you care about. Maybe you care much more about correctness and completeness based on your use case, but maybe it just needs to be relevant and clear. And then that kind of wraps up our main LLM as a judge implementation, and it brings us more into what gaps do we still see? What else might we want to evaluate here? And essentially, as we see it here, are 4 points. One of them is routing. So and that goes kind of more into the granularity of how we evaluate our applications in detail. So if you build agentic frameworks, you want to make sure that the right agent is called at the right time, that the right tool is used, that every part of it is working as you expected. So this is more about making sure that your agentic workflows are taking the right decisions and turns in answering questions. You could think about formatting as well. So if you've ever used ChatGPT, then you might know that ChatGPT is really beautiful in displaying equations, in displaying tables, maybe even graphs for you. And making sure that that is the case can actually be super useful or not relevant at all, depending on what your use case is. So if you work in an application that is based on a lot of mathematical formulas, you want to make sure that your LaTeX formulas are always formatted nicely, because otherwise they're not readable to the audience. As opposed to if you're just having a chit-chat chatbot, maybe that isn't that important. Question types. So what we found quite a lot is that our chatbots work really well for certain question types. And really, when I say question types, I mean like types of how you might ask a question. And you can obviously think about multiple ways of asking the same thing in different ways, but your chatbot might be able to respond to one way much better than another way. And that's something that you can very easily also evaluate with these types of frameworks. And then finally, and almost most importantly, content safety. We want to make sure, whether it's an internal or an external application, we want to make sure that what our chatbot returns has the right tone, doesn't contain false or misleading or offensive information, and is just overall following content safety guidelines. And then finally, some lessons learned. As you can imagine, this was quite a long process to come, and a lot of experimentation has went into how can we optimize large language models. So a couple of lessons that we think are worth sharing. One of them, and this is actually something that can't be repeated enough, is follow software engineering best practices. We want to make sure that what we're building are scalable, reliable products. And for that, it's very important to make sure that code is well tested, well maintained, and just overall following software engineering best practices. 2 points that I wanted to highlight here are building a reusable library. Natalia has touched upon this earlier, saying that if we implement a system for evaluation, it's only useful if people actually use it. If we build it in such a way that it's a massive obstacle and doesn't really work, it's not really clear how to use it or implement it for your own application, people will be very reluctant to using it. So one very important thing here is make it easy for people to use it, lower the barrier to entry, and the way we propose to do that is by having a reusable pip library that can do that for us. And then the other one is thinking about non-functional requirements. And that's something that we haven't talked about yet, but I think I've mentioned earlier that when we evaluate these applications, we want to make sure that we evaluate them across a reasonably sized test set. So if you ask ChatGPT one question, you'll probably get an answer within 20 seconds. But if you ask it 500 questions, it might take you 30 minutes. If I tell a developer that you need to evaluate the system now, but it'll take you 45 minutes to actually evaluate it, they're probably not going to do it with every time that they make a change in the code or every time they raise a pull request. So what we propose, or what we've learned, is that it matters to make this really easy and really fast and really reliable. So by multi-threading LM applications, we can now evaluate hundreds of questions and answer pairs within minutes rather than over the course of half an hour or an hour. Yeah, I already touched upon that as well. A representative test set. We've seen quite a lot of use cases over time that came to us and said that they evaluated their application and then had 5 to 10 test questions that they evaluated it with.
That's my favorite one. It's like, yes, it's reliable. How do you know? My specialist tested on 10 questions and the answers looked great.
And that actually goes back to what we said earlier, that SME time is really valuable and very limited. So an SME will probably not sit down with developers every day to test through 100 different questions, whether now this has improved it or not improved it. But it's still very important to go through this test set and making sure that our test set is representative. Asking the same question in different ways 200 times isn't really helpful, especially if you have a sophisticated agentic framework. But having a test set that really covers edge cases is what you want to be able to do this reliably. And one other thing that I've kind of just put in here, it should be consistent over time. One thing that we found is that many applications actually have data that changes very regularly, whether it's database data, anything that you ask a question about data that you have in a database and you ask what's my most recent, whatever it may be, that may change the answer between what it is today versus what it might be in 2 weeks' time. And then finally, consistency. This is also something that gets challenged quite a lot. Natalia mentioned earlier that people see in the news that ChatGPT makes up things and are very quick to jump to the conclusion that testing it with ChatGPT may not be the most reliable way. So it's really something about building trust, making sure that you show your end users and your developers that your test set and your evaluation framework is consistent. If you run it over the same question 5 times, it gives you 5 times the same result. That's really the ambition for this. Then finally, lessons learned in terms of ways of working. You can't really evaluate too much when it comes to these applications. We've mentioned earlier that you can make a very tiny change, maybe even just one line in a 100-line prompt, and that may have a massive impact on your overall performance of your chatbot. So really what we recommend and what we try to enforce in our cycle, run through a couple hundred questions and make sure that the results are looking good for that. And here is again what the human in the loop comes in. As I mentioned earlier, what you want to use this for is not a black and white solution of the score is better for this pull request than for the master branch, therefore this pull request is better, but rather the way you can use it is where are differences in my responses? And that's something that this framework excels in. making sure that you highlight, okay, this answer got slightly worse from this iteration to the previous iteration, and then you can dive into this one question that got worse, as opposed to having to evaluate 100 questions that may have stayed exactly the same. Yeah, and then obviously you can use it for regression testing before releases, as well as for ongoing monitoring in production use cases. But really, the key message here is use it as much as possible, and you can't really go wrong with evaluating too much. I think with that, I'll hand over back to Natalia.
I have one glorious slide here. No, but I think I understood that there are two topics we haven't covered also in slides. So I think building your test set, I think it can be used, like you can use creative ways, and you can also use LLMs to create this test set. So not always a poor human being needs to produce 500 questions. So you can use LLM to generate them, or at least augment the way they're asked. So like don't make people like do all 500. And then the second one, I understood on motivation. We didn't answer the question why building our own instead of using off the shelf. What we found at the beginning, there were so many different ones. So you would come to a project and the project would be like, yeah, I'm using, I don't know, Ragus, I'm just using something else. And all of them would use completely different ones. So you wouldn't have any consistency. So for example, for governance process, when I would ask a question, so is it reliable? Should we go into production? You would get some scores, but you don't know how they produced, whether it was done. And many implementations were actually done not using frameworks, but people were doing, there were, I don't know, 5 different projects doing different way of measuring groundedness. So having one, you can say, just use that one. We trust it. We know, we checked it works. Makes life of everyone much easier.
Maybe to add to that also, what you just touched upon is that by doing that ourselves, we have full control over what it does behind the back. So if someone comes and challenges it, well, why has it told me that it's not grounded? We have a very strong understanding and can look behind the scenes and say it scored it this way because X, Y, and Z, and that helps a lot with building trust with stakeholders.
And I think we managed to have some trust and evaluation. So what Fred mentioned, so initial discussion was like, so you use one LLM to kind of like judge another LLM. So it will be like, you know, AGI is coming and taking over the world. So, but it's consistent and you can rely on it. So we said we don't want to drop humans. So we want human be in the loop from time to time, checking, randomly checking, and providing like a different angle to it, but it just speeds up the process. And cost, so yeah, comparing to SME time, I told you, there can be some specialist who is one in the world in, I don't know, actually in drilling business where I come from, there are some specialists who are like, I won't say one in the world, but there are just a couple of them. Their time actually much more expensive than any LLM calls. We haven't seen any place, any kind of like case where it was so expensive that we would have to think about, I don't know, hosting our own or doing something. We are using our cloud providers for all the things we're doing now. So it's not as expensive, even though it looks like a lot of calls, and also you can optimize things if you hit that barrier. So, okay, so actually we move to Q&A, so you can throw questions. Oh, I can see.
Yeah, the human in the loop. I might have missed that. So the human in the loop, do you evaluate the your PR as well as part of your CI/CD?
Oh yeah. So obviously, like you have a developer who relates PR and everything. It's just when you develop, it's trying to remember how pre-commit tests, I think that would be called. So before you commit, like it does the test and says like it didn't like go like super bad. So you still have all like evaluating your pull request and everything there. It's just additional measure to you to say, you know, it's in software engineer when you will merge a pull request, it will go through the tests before even like anyone looks at it. So yeah.
So it's like the QA bit that you do afterwards. You evaluate the performance of how does your change affect the end system, but you still do all the normal software development checks of, you know, anything like pre-commit hooks. You still have your unit tests, you still have your integration tests, you still make sure that your software engineering quality is good.
And this human in the loop is actually for your LLM evaluator, not the stuff that you're evaluating with your evaluator.
So there's different ways of how you can go about it, but one thing that we found really helpful is to use your framework to assign basically scores, so to score your answers of your LM, and because it's quite consistent and reliable, if the answer is basically the same between your two iterations, it will score it the same way. But then you will have answers that you change something in your chatbot system and the answer is substantially different, and then you will almost always get a different score for that. So then your human in the loop goes and looks at the differences between that, because there's no sense in a human then going into and looking for 200 questions and making sure that the ones that worked before and still work, or never worked and still don't work, the more common approach.